Okay, welcome to the second Virtual Office Hours session for the 2014 POSA MOOC. We have a number of different things I want to cover today. One of the things I want to do is show my solution to assignment 0, and we'll talk about different ways of implementing it. Then I also want to go over some of the criteria for grading the assignment 0 solution. As you've seen, there's been lots of discussions out on the discussion forum about this, and so we can summarize those things. And then I'll also talk about next week's assignment, actually the one, sorry, not next week's assignment, the one that's due next week. And we'll go through that. And then, of course, if there's any time, I'll also be happy to answer any other questions as well. So let me just go ahead and kind of clear out all the queue of questions so I can see real questions from everybody else who are saying hello. It's nice that you guys joined us. And hopefully this will go smoothly. By the way, if you're wondering why the background is green, I'm going to have some fun later when I'm done with this and see if I can go ahead and put a different background in there when I release the actual version of this, just for kicks. Okay, so the first thing I'd like to do is show you my solution for assignment 0. And as you no doubt have figured out by now, assignment 0 is really simple, intentionally simple, but people still had some challenges. Some people still had some challenges with it, and so we'll go ahead and talk about those as we go through this. So here's basically the original version, version 1, as opposed to version 2. This is the one that was released on the website. By the way, always make sure that you follow the instructions that are in the website. That's the peer assignment and assessment website. Don't look at anything else except that in order to get your guidance for what to do. Hopefully we will not have any problems with this, but just wanted to make sure that we'd be okay. So here then is the test queue method that was the bulk of where you had to provide your implementation. As you all know, you just do to do, and you find where you need to fill it in. So here you had to fill in the methods to go ahead and start this stuff off. Let's see, and I think this is sort of a hodgepodge of different implementations, but I'll fix it. So this should be the right one for the original assignment. So you go ahead and you create a new thread, passing in the consumer runnable, and then you pass in another thread, passing in the producer runnable. Those things, of course, are defined earlier as runnables. That just creates the threads, and then the next thing you do is you go ahead and start the threads. You can start the producer, start the consumer, and once you do that, then you can go ahead and let the thing sleep for a little bit, just to give it a chance to do some running. And then finally, or not finally, but the next thing you do is you go ahead and interrupt the consumer and producer, and then you go ahead and join the producer and consumer. And it really doesn't matter which order you do this in. You can do the consumer first or the producer first. It shouldn't matter. The main difference is you'll probably see somewhat different errors if you were to run this thing with the buggy version, which we don't have in the actual assignment, but with the original assignment we had a buggy version, buggy blocking queue. And the order in which you created the threads and started them and so on would have a little difference in terms of what errors occurred. So honestly, that's really all there is to it. As you can see, it's very simple. And if you take a look at the grading rubric, which we will do here in a second, then you can see how to go about grading this. So it's only a handful of lines of code. By the way, some people did some unusual things. Some people, for example, put a sleep statement down here to wait for the threads to exit. That obviously is not a good solution. It's not stable. Using sleep is a bad idea. Instead, you should do a join. That's what you need to do. Some other people had asked questions about looping, calling is alive. That's obviously not a very good idea either, because you're burning up CPU cycles for no particularly good reason. So let me just stop for a second and see if anybody has any questions about this particular implementation. As you can see, it's really simple. Okay, doesn't look like any questions. That's fine. If you have questions, feel free to ask them. I guess the other thing I should mention also is that some people mistakenly did the wrong version. They did this version, and if you did version 2 by mistake, we'll talk about how to grade that in just a second, but basically version 2 is very simple. Also, it's the same basic lines of code that just they're implemented now as hook methods using the template method pattern. And we talked last office hours about why we did that, and of course the reason for using the template method pattern is to be able to decouple the code that you write from the code that calls this code. So if you were to go here and take a look at test queue with this new template method approach, you have a bunch of abstract methods, and then you've got the template method, which invokes the various methods on the abstract methods. Okay, let's see. Now we got a bunch of questions. Let me go ahead and we'll talk about the questions. Question number 1. One person had a try-catch block at the join part. Let's go back over here, just make sure that I know what you're talking about. So here's the synchronized queue. I'm assuming that the person must have gone ahead and done something like this. Try, blah, 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 catch, something or other, who knows what, etc. So in this particular case, that's probably overkill. I don't see that there's going to be an exception that's thrown there that we actually care about. So I wouldn't worry about it as long as their program worked. That's just more than they need to do. Let's see. Have another question here. Let's select this one. Can you release the flow of the programs also? Not quite sure, Enmol, what you mean by release the flow of the programs. Do you mean draw sequence diagrams that show how the flow goes? I could do that, or you could basically download a tool like ObjectAid that plugs into Eclipse, and you could generate out things like the class diagrams and so on. Probably a good exercise to learn how this stuff works. It's really, really very simple. So if you have specific questions, I'll be happy to answer them, but I think that you've got to get used to reading code. That's probably the most important thing. Let's see. Here's another question. Can you please comment on this? Let's see if I can get to it. Can you, Ramnath, do you mind giving me something that is a title? I can go over here and look at the discussion forum. I don't know exactly what you're asking about. Is this something that's in, if this is something in virtual office hour forum, we will come back and talk about that later. So let's see. Let's see if we can find something here. See if I can type it in somehow. .685. Okay. So here we go. Joining only one thread. Yeah, I would have to take a longer look at this to understand your question. I'll go back and look at this later. You know, basically, what I think it's most important to understand in this context is that this is why we have people actually reviewing the code as opposed to trying to automate it. One of the things you discover is that there's many, many, many different variations of getting things wrong with concurrent programs, and so trying to write a tool that would automatically evaluate this stuff is probably going to be just about impossible. Okay, I'll come back and answer some of the other questions here in a second, but I wanted to go and talk about the grading rubric, because I think this is a question that a lot of people have. So let's go ahead and do that. I'll go share a screen that has the there we go. All right. So let's go over here and take a look at the assignment. So you can go in here and click on it. This, of course, is where you need to go. Again, let me reiterate this just for emphasis. Do not take a look anywhere else for the instructions on how to do the assignment except here at the Programming Assignments and Assessments page. Do not look anywhere else. It's always going to be in here. Everything else that you see is basically considered prototype until it goes up here. So don't get confused by the wrong stuff. So here were some of the criteria. It says very explicitly, submit a file containing your synchronized Q.java source code. So some people got confused somehow. They didn't read the instructions, and they submitted synchronized Q impl.java, which is version 2. I personally think that if you're going to be a good software developer, you absolutely need to understand how to read the requirements, and you have to be prepared for change. That's part and parcel of being a good software developer. Things are not going to get handed to you in a way that's always 100% stable from the beginning and stays that way forever. So it's important to read the requirements carefully. And if you have questions, ask them, and then make sure you follow up to see what's going on. So I personally would not score people if they uploaded the wrong file for this. But if people want to take mercy on them and give them a point, it's not the end of the world. It's not a zero-sum game here. Having people score an extra point does not detract from anybody else's ability to pass the class. If they do upload the wrong file, then you're going to have to decide if you want to check and see if things compile. Fortunately, it's pretty easy to look at the code to see if it's right. Now, the rest of the things down here, questions number 3, 4, 5, 6, and so on, in that particular case, if they submitted the wrong file, just take a look at the code. You should be able to tell at a glance whether it's correct or not, having seen the right solution. I don't care whether they do one thing versus the other first. That shouldn't matter as long as the results are correct. So, if people submit the wrong file, feel free to give them full credit as long as they create, start, interrupt, and join with the threads properly. And of course, they also have to make sure that their solution correctly passes the array blocking Q test in synchronized qtest.java. Now, another thing to point out, just because it bears repeating, just because code passes a test doesn't mean the code is correct. That's true, of course, in any kind of code. It's even more true in concurrent programs because depending on characteristics like the number of cores your hardware has, the properties of your virtual machine, other factors like other background load, you will get different behavior in many situations. Things don't always execute deterministically. So that's why it's also important for people to carefully inspect the code, not just run the test case. And in some sense, the peer grading approach we're doing here is actually a wonderful lesson in how to inspect code written by other people to make sure it's doing the right thing. So even though it's a little bit of extra work for everybody, number one, it's pretty much next to impossible to write bulletproof regression tests that are automated, and it's certainly more than we have the time to do. If anybody gets inspired and wants to write such tests, we would be happy to accept them, but I think you would quickly discover it's very hard to do that. They'll give you the right answers all the time. So inspection is very, very valuable. So that's basically what I want you to do in terms of evaluating and grading the code. So if somebody submits the wrong file, give them credit for the things that are correct. It's okay to take a point off here or there because they didn't follow the directions, but as you'll see, that will not should not fail people from being able to succeed in the class. Okay, next question. Let's answer some questions here. Question is, what is meant by inversion of control? So if you take a look at the various videos, if you take a look at the video from the introduction section, I think it's the overview of patterns and frameworks video, it talks about inversion of control. And inversion of control is often called the Hollywood principle. For those of you who watch Hollywood movies, it's called the Hollywood principle. And the reason it's called the Hollywood principle is because in Hollywood, They say, don't call us, we'll call you. If you're an aspiring actor or actress and you want to be a movie star, you have to wait till the famous directors and producers call you up. So they call you back. So inversion of control simply means that the program doesn't control the event loop, but instead it's controlled by the framework, and you register various kinds of handlers that get called back when things happen. And if you take a look at the many, many, many examples we have in the videos of concurrency frameworks in Android, you will see inversion of control. So handlers that we talk about with a hammer framework, the handlers like the handle message method that gets called back, or the run hook method that gets called back, that's inversion of control because you register the handlers with the framework and it calls back your hook methods when things happen, when people pass you runnables or they pass you messages. If you take a look at Android in general, you take a look at the activity lifecycle hook methods. Those are good examples of inversion of control. Very shortly, we're going to have a bunch of videos on services, and services use inversion of control. So inversion of control is one of the fundamental principles of a framework in general, and it's used very, very, very heavily in Android. In fact, there's really pretty much no self-directed applications in Android at all. Everything is driven by callbacks and hook methods from one or more frameworks. Okay, another question. By the way, if I don't answer your questions fully, feel free to ask Variant and I'll try again. Can you give more explanation in real-life use case of the gang of four pattern? Well, if you tell me which one you'd like, I'll be happy to give you an example of it. But there are lots of great examples of gang of four patterns in everyday life. For example, if you want to go buy property, if you want to go buy a house, you probably talk to a mediator who works on your behalf to talk to the sellers and you, the buyer, and they mediate that communication. That's one nice example of a gang of four pattern. If you have a problem with a help desk and you can't get your phone or your modem to work, and you call up your service provider, then chances are if the first person you talk to can't solve the problem, they pass it up the line, and that would be an example of the chain of responsibility pattern. There's just lots and lots and lots of examples. So give me a specific example and I'll be happy to talk about it. This is, I think, I'm not sure if this is a question or a statement, Object Aid. Object Aid is a toolkit you can use with Eclipse to be able to generate UML diagrams. I use it in some of my slides to do the structure or class diagrams. The class diagrams are free. You can download the plugin and install it into Eclipse, and you can generate class diagrams for free. If you want to be able to generate structure diagrams, sequence diagrams, I think it costs you a nominal amount. What is a serializable class? That's a class that can have its state, which would of course be in the form of fields or data members, converted into some kind of parcel or bundle, which can then be passed across address spaces and reconstituted, deserialized on the other side. We will talk about this concept when we get a little further along into the communication portions of Android, which is coming up in a couple weeks. So things like the Android binder mechanism that allows you to be able to do inter-process communication between Android activities and services and so on. You can use basically parcels and bundles to serialize the data and pass it back and forth between the address spaces. Let's see. This person was just asking what's the name of the software that I just mentioned. That's called Object Aid. Very cool stuff. I am new here. It's my first time. Please, can somebody help me? So, well, you might need to be a little bit more specific in terms of what you're looking for. In terms of the help, I can't give you help in the abstract. But if you're brand new to programming, let me point you towards something that might be helpful. Let's see if we can find ourselves a browser somewhere, and I will point you to something that might be useful. Let's see. The interface here is a little bit clunky, but I think I can make it work. How about that? There we go. All right, so let's take a look. Share the screen. If you are brand new to this class, then I highly recommend that you go here to the FAQ. The FAQ is available through the navigation bar, and I would scroll down here a little bit, and it says something like, let's see, is it necessary to have taken the first course? So that would be a good one to read. If you haven't taken the first course, I would read that. I would also read FAQ item number 3, which talks about the assumptions and expectations about students taking the MOOC. So this kind of tells you how the course was designed. The course is intentionally not designed as vocational training. There's lots and lots of videos you will find on YouTube where people will walk you through code examples line by line. We do a little bit of that, but that's not the goal of the course. We're here to do education, and a lot of education involves seeking out the answers on your own. And we give pointers to the stuff, and we provide an overview in the class, but you'll have to go out and find other things and follow up on stuff. There's also, here's the question. Question number 5. Can you take the course if you have no prior experience programming Android or Java? So if you don't know Java, it's probably not the course to start with. If you don't know Android, it's probably not the course to start with. And this particular FAQ entry gives you some suggestions and tips on where else to go. We will rerun this course as well as the other courses in the mobile cloud computing with Android specialization at a later point starting in the fall. And so if you find yourself struggling to understand what we're covering because it's going by too fast or you just don't have the background, I highly recommend you take a look here and follow some of the suggestions to learn the basics first. Otherwise, you'll just be very frustrated, and we are not designing this class intentionally for people who are brand new. All right, let's see. The time is used guarded blocks. Let me see if I can figure out what the question is here. Why factory method pattern can use inversion of control? So I'm not entirely sure I understand the question, but typically you use guarded blocks when you're using condition objects or you're using the built-in Java monitor objects. So condition objects are covered in the condition object, the Java condition object video, and Java monitor objects are covered in the Java built-in monitor object video. Those are all part of week 2 lectures. So I recommend you take a look at that. They both talk about something called the guarded suspension pattern. And the guarded suspension pattern is the pattern that you use when you use guarded blocks. So take a look at the videos. You'll see lots of examples. You'll get a chance to do some examples of this when you program assignment 2 for week 3 involving semaphores. And so that's basically guarded blocks. And you use them when you want to defer entering into some critical section until some condition expression is satisfied. And why is the factory method pattern used in inversion of control? So factory method pattern really isn't used for inversion of control. It's a creational pattern, not a behavioral pattern or a structural pattern. And it's basically just used to shield the user of some object from the process necessary to create the object. A great example we always use when we talk about factory method is we say, sometimes you don't want to know how the sausage is made. You just want to eat the sausage, but you don't want to have to know how the sausage was actually created. In other words, slaughtering animals and pulling out their intestines and all those nasty, ugly things. You just want to have a yummy piece of sausage. Same thing is true with how legislation is passed. You don't want to have to know all the backroom deals that went into making the legislation. You just want to have the laws that help make a safer environment or whatever. So same thing is true with factories. Factories are used to shield you from the details of how things are created. And there are lots and lots and lots of examples of using factories in Android and Java and all the examples we show here in the class. Let's see. I like the human relatable design pattern analogies. I like those too. Let's see. Is there a central resource area that collates all these examples? So if you read the POSA books, like POSA 2, POSA 3, and so on, the pattern-oriented software architecture books, we always try to give a human known use example for every pattern that we have. So that's one good place to look. You can learn about the POSA books if you go to my website. Let me bring this up. It's probably worth knowing about this just because you will find it useful, hopefully. Here we go. If you go to my website and you look at POSA, Pattern-Oriented Software Architecture, you'll see links to all 5 of the POSA books. And the first one I was heavily involved with was so-called POSA 2. Many of the patterns we are covering in this MOOC are documented in the POSA 2 book. What's so funny, historically, when I wrote this book with my colleagues from Siemens, I was doing a lot of work with C++. I was doing a lot of work with distributed object computing and object-oriented concurrent network programming with toolkits like ACE and Boost and so on. And we discovered all these patterns, we documented them. And that stuff is still being used today. But what was really fascinating for me is I started to work a lot more on Java and Android over the past couple years. I began to realize that many of these patterns that were in the POSA 2 book that we did with C++ and ACE also occur in Java and Android, just demonstrating the fundamental essence of these patterns. And if you take a look in the books, you will find human known uses. I'm not aware of any other place where people codify lists of these things, but if somebody wants to take the time to put them to the POSA wiki, that would be kind of fun. If we rewrote play ping pong to print 3 different strings, would we have to give 3 semaphores to the constructor? Yes, you would probably have to have a semaphore for every different thing you wanted to wait on. I haven't tried to do that yet, but I don't think it would be too hard. It would just be somewhat tedious. By the way, people often ask the question, is it possible to do the ping pong program with just 1 semaphore? And the answer is really no, or at least I've never seen anybody who was able to do it correctly and consistently correctly. But you're welcome to give it a shot, and if you figure out how to do it, let us know. Using 2 semaphores is very simple. The way to think about it is kind of like traffic lights at an intersection. If you want people to take turns, you need to have a traffic light in each direction. Otherwise, they would get confused. What is a native implementation of sleep lock in Android? Well, the great example, of course, it's part of the Java concurrency libraries, would be the condition object and the semaphore. If you watch the video that talks about an overview of Java synchronization and scheduling mechanisms, if you watch that video, it's the first video from week number 2. What you see in that video is that we give an overview of the various Java concurrency mechanisms we're going to cover that week in week number 2. And one of the things we do is we talk about sleep locks and we talk about spin locks. And as you'll see, sleep locks are implemented using semaphores and condition objects, and under some conditions other things will sleep as well. They typically try to spin first, and then if they can't get what they want quickly, then they'll go ahead and sleep. Those are called adaptive spin locks. They spin first and then sleep later if they can't get the resource to avoid busy waiting. So a condition object is a great example of a sleep lock. If the condition is not satisfied, then you simply wait on the condition, and that puts your thread to sleep on a wait queue, and you're not awakened until somebody calls signal or signal all on that condition, which then wakes you up, and you can go ahead and try to acquire the resource again. Great, another question. By the way, these are really excellent questions. I'm very impressed. This is the fun part of the course is talking about the technical issues. It's less fun talking about things like grading policy or whether or not we have too many links in the videos. That gets a little old after a while, but answering the technical questions is really fun. What's the difference between signal and signal all in the condition object class? So if you watch the video, it explains the difference between signal and signal all. Signal will typically wake up one thread, signal all, one thread that's waiting on the condition. Signal all will wake up all of the waiters on the condition that are currently waiting. And there's a whole big discussion of this that you can read about at the end of the monitor object pattern. There's a discussion about signal versus signal all, and I give a link to a Stack Overflow article that talks about some of the subtleties there. In general, if you're using condition objects, you can usually just use signal. If you're using built-in monitor objects, you're often forced to use signal all, which is less efficient and somewhat error-prone, but it's kind of necessary because of the fact you can only have one weight set per object with a condition object. Oh, sorry, not with a condition object, with a built-in monitor object. But with a condition object, you can have multiple weight sets per object, per Java object, and therefore you can have more selected notification. If you also take a look at the very end of the video on monitor objects, you'll see a link to a pattern written by a guy named Tom Cargill many years ago on the specific notification pattern in Java. And he talks about some of the limitations with built-in monitor objects and talks about how you can use so-called specific notification. And Java condition objects make specific notification very, very easy to do. Let's see. Oh, here we go. Last office hours, I gave a real-world example of the Gang of Four bridge pattern, where you're electing different presidents, which could be more than that. Can you elaborate and contrast with the Gang of Four template method pattern? Sure. I think you mean template method, not template, because that's what it's called. So the idea with bridge is that you have a common interface. The somewhat humorous example I had was a president of the United States who has certain authority granted to him or her by the U.S. Constitution. And I'm sure those of you who live in other countries with premiers or prime ministers or whoever the people are, chancellors, it's the same basic idea. You have an office and you have a person who implements that office. And of course, those people may be very different. They may have different personalities. They may have different policies and so on. But there's certain things that they have in common. They have to maybe give a State of the Union address every year to talk about how things are going. That's mandated. They have the responsibility of proposing a budget. They can make executive orders and so on. They can declare war, etc. And so those are examples of the interface that's provided. And then you have different implementations of that interface. And that might be the specific people who actually hold that office. So that would be a simple example. Of course, it's not entirely accurate, as with all analogies, there's some defects, but it gives you the idea of an interface and then something that implements that interface. The template method pattern, in contrast, has a particular interface, a method that is used to do something, but that particular thing can be varied selectively by subclasses from the original base class. And so a great example, as we see in the ping pong example, the ping pong program, the concurrent ping pong program, is we have an interface that's called run, or we have a method called run, and the run method goes ahead and calls acquire and release in a loop. So the run method is the template method, and then we have hook methods, or what are called primitive operations in the pattern, and we have acquire and release. And so the actual code is identical. It's always the same. In fact, why don't I go and show you what I'm talking about to make this point a little bit more clear. Let's go ahead and share my screen as I'm talking. So let's go ahead over here and we'll take a look at the code. This is example ping pong console source, and we come down here to play ping pong Java. Hopefully you can see this, and we search for the run method. Here is the run method. Run method is in a class called ping pong thread. As you can see, it has a pair of abstract methods, acquire and release, and run goes into a loop. This method has a fixed set of steps in a base class, and as it runs, it calls acquire to grab the lock, it does some work, and then it calls release to release the lock. Acquire and release are hook methods or primitive operations, as the pattern calls them, and those are defined by subclasses. So down here we have ping pong thread sema, and its acquire and release methods acquire and release the semaphores in the right order. That's what they do. And then we have ping pong thread cond for condition object, and its acquire and release methods do something a little different. They implement the semantics using condition objects, not semaphores. But notice how cool it is that irrespective of the fact that the acquire and release methods differ in their implementation, the template method called run is absolutely 100% always the same. So by using this pattern, as we talk about in some of the videos from this week, it helps to enhance so-called systematic reuse, because we can have the code fixed here, and then we can vary things selectively. I would have to think a bit about real-world analogies for template method. Let's see. How about something where you're giving a lecture and you've got a certain set of slides, and you're going to customize the way in which you present the material based on the experience of the audience. So if the audience is very experienced, you will go through the material very quickly, but you'll keep to the same topic, you'll keep to the same subjects, those will be fixed, you'll cover them in the same order, but to the degree of detail you'll go into would differ depending on your audience. And so if you're talking to an expert group, you would keep it pretty high level, and you would just cover the material and just talk about the key points. Or if you're talking to people who don't want to know the details of programming, you just give them a quick summary. But then if you have people who need more explanation, then you would go into more explanation. So there's lots of examples in the real world along these lines. All right, let's pop back here and answer some more questions. Let's see. The code for this week, and I'm not sure which week this is took almost a half hour to run for multiple threads. So Sheila, by this week, I'm assuming you're referring to assignment 0. If you're not assuming to assignment 0, then please correct me. But if you're taking that long to run, it's probably because you're not handling the fairness parameter correctly. For the first 2 assignments, there is no fairness parameter. For the third assignment, there is, for assignment 2, which is the third assignment. For the second assignment, the one that deals with the locks, you don't need to be fair, and so as a result, that should speed things up quite a bit. But yeah, you can certainly crank down the number of iterations. It should succeed or fail very quickly. How do you compare the bridge pattern with the strategy pattern? Great question. By the way, I actually have I will answer that question in 1 second, but I want to also point you to something else which will give you lots and lots and lots more information on this topic, probably more information than you could ever want. But if you go to my YouTube channel, if you look me up on YouTube, then let's see, we will find CS251. So if you go to CS251, this is a series of screencasts from a course I taught at Vanderbilt last semester that covers basically object-oriented design and programming using C++ and patterns. And there's about 24 hours worth of videos here. There's a lot of stuff here. And basically, if you watch this, you will eventually get to a discussion in the class where I go into great detail explaining the differences between strategy pattern and bridge pattern. In a nutshell, the short version of the question is the bridge pattern defines an interface that clients use directly. The strategy pattern, and that is called the abstraction. In the bridge pattern, you have an abstraction which has methods like open, close, read, write, and then you have an implementer hierarchy which has typically the same methods, except those are defined as virtual methods that are called back through virtual pointers in C++ or Java or even C for that matter. So in that particular case, you, the user, will directly access the bridge implementation through the abstraction interface. With strategy, in contrast, you have something called a context, and in the context goes all the state that doesn't fit neatly into the strategy interface. And then you have something called the strategy hierarchy, and the strategy hierarchy has a base class of some kind that has virtual methods defined on it, that has some abstract steps in an algorithm, for example, and then you subclass from that to define the concrete strategies. And the context that you see there is used by those concrete strategies to access information that doesn't fit neatly into the one-size-fits-all strategy interface. So if there's some things you just can't use with the strategy interface, then you can use that through the context. But you as a user of strategy don't access strategy through the context. Whereas with the bridge pattern, you do access the bridge implementation through the abstraction. So that's one of the differences. The other difference, at least in the Gang of Four taxonomy, is that strategy is a behavioral pattern, whereas bridge is a structural pattern. That distinction is somewhat arbitrary. For my money, when I typically use this, I almost always combine bridge and strategy when I program in C++. So bridge strategy is a pattern compound. We will put out a set of videos that are optional for this coming week that'll be on pattern compounds, and you'll see bridge strategy is a nice example of a pattern compound where you can typically vary the implementations, perhaps even dynamically. Now, just another point, you didn't ask this point, but it's important to recognize. Always be aware that the Gang of Four book gives you some canonical examples of the patterns, but there are many other examples of the patterns that don't look quite like the Gang of Four book, but they're still the pattern. So a good example would be in C++ standard template library, you have something called functors, and functors are typically used to direct the way in which algorithms or containers behave. For example, the sort algorithm in STL can take a functor that indicates whether to sort in ascending or descending order. In that particular case, that functor, which does not have any virtual functions in it, by the way, is a strategy object, or sometimes called a policy object. And so that's a good example of using strategy to vary the behavior of an algorithm without following rigidly the Gang of Four structure diagram. If you read the Gang of Four strategy document, the documentation of the pattern, they actually mention that as a variant. And the reason they mention that as a variant is when I reviewed the book, I was a reviewer for the Gang of Four book. I was also learning the C++ template mechanisms at the time. And so I mentioned to them, hey, you know, strategy pattern could also be done with templates. And they said, oh, you're right. It's just an example of earlier binding or static binding. So they added that to the book. And the STL in C++ is full of strategy objects that are used that way. Here's another question. I often read about preferring composition over inheritance. Could you elaborate on this, and how is it applied to the Android framework? So this is going back to the early days of object-oriented design. Back in the early days of object-oriented design with languages like Smalltalk and Simula 67, people tended to get pretty crazy with inheritance, and they'd have very, very deep inheritance hierarchies that were hard to understand. So over time, as we had other mechanisms like templates and other ways of being able to do object composition and so on, people started to realize that using patterns like strategy that are more black box oriented is often preferable to using patterns like template method, which are more white box oriented. And in fact, you'll see when you take a look at the videos coming out for this coming week, we talk about the black box, white box framework comparison. This is something that shows up quite interestingly in the Android async task framework, which contains elements of both black box and white box frameworks. So as a general rule of thumb, white box frameworks, which typically use inheritance extensively, are much easier to develop but harder to use because you have to understand more of the details of how they work. In contrast, black box frameworks are harder to develop but easier to use. Now, I don't have time in this particular discussion to explain this particular point in detail. However, if you just can't wait until next week's videos come out, you can go to my YouTube page, bring this thing up, and you can click on the POSA MOOC 2014 playlist, and if you scroll down a little bit, you will find the async task framework discussion, part 1 and part 2. And I believe that the discussion about black box versus white box frameworks is in the async task framework part 2 video. So you're welcome to take a look if you'd like to kind of read ahead. This will come out next week on the Coursera site, but you can see it here, and you can read about the async task, or you can watch the async task framework, and you'll see a whole bunch of examples of black box versus white box frameworks. You'll see about strategy pattern versus template method pattern, And that's basically the essence of composition versus inheritance. In practice, I often combine both of them. I tend to like very shallow inheritance hierarchies that then use composition and strategies in order to be able to delegate to do the work that needs to be done. And if you watch the CS 251 videos on my playlist, you'll also see lots and lots and lots of discussion comparing these approaches. And as I just said, the Android framework has examples of both. So the async task framework uses white box or inheritance for being able to subclass the various hook methods to do on pre-execute, on post-execute, do in background, and so on. And those are white box techniques using inheritance. And it also applies the strategy pattern and black box techniques to be able to vary the type of executor that's used to execute things concurrently. Let's see. I'm not sure if this is a question. Services occur on background threads. The main thread is reserved to UI. I'm actually working on a video right now that talks about services. Keep in mind that services do not run in background threads by default. You actually have to spawn those background threads or leverage built-in frameworks that come with Android, like the intent service framework. So if you do that, then services run in background threads, but they don't do that by default. They actually run in the main thread, believe it or not. Kind of funny. What is the difference in terms of an implementation between an interface and an abstract class? Oh, great question. So in Java, they give you interfaces, and then they also give you abstract classes. As you probably know, you can't define data members in an interface. You can only define interface methods, just methods, and all those methods are, by their very nature, abstract. Whereas with an abstract class, you can define methods, and you can also define non-abstract methods in an abstract class. So you can give more implementation guidance or more implementation artifacts in an abstract class than you can in an interface. Let's see. So it really comes down to your personal style. If you're programming in Java, the need to use, if you're implementing the bridge pattern in Java, then you often just use an interface, and then you have implementations of that interface. If you're doing it in C++, you'd often actually have an actual class providing the abstraction as opposed to an interface, because there are no interfaces in C++. So the need for the bridge pattern in Java is typically minimized, although if you take a look at the Java concurrency mechanisms we cover, things like reentrant lock, read-write lock, and so on, you'll see that they all use the bridge pattern for the reasons described in the video. But that's not common. In Java, bridge pattern tends to get used a lot less. That's because you use the bridge pattern in C++ frequently to deal with reference counting and to try to do automated garbage collection or semi-automated garbage collection using reference counting, whereas with Java, you don't need to do that. So I don't know if there's any hard and fast rule. I use interfaces if I just need to define an interface with no implementation artifacts. If I need to define implementation artifacts, I use an abstract class. Aren't most design patterns just different implementations of polymorphism? You might come to that conclusion if you limit yourself to the Gang of Four book. But even there, as I just mentioned with the strategy pattern, unless you define polymorphism to also include templates, which you certainly can, many of the Gang of Four patterns also are not just about polymorphism. But if you start to explore much further beyond the Gang of Four book, which I strongly encourage you to do because the Gang of Four book is an awesome book, but it's very limited. It would be sort of like trying to become an expert in mathematics by only studying algebra, right? There's a lot more to being a good mathematician than just knowing algebra or just knowing basic addition and subtraction. So learning the Gang of Four patterns is like learning algebra, but at some point, if you go further, you need to know calculus and other forms of mathematics, the differential equations, and so on. So if you start looking at the POSA books, lots and lots of patterns there, little or nothing to do with polymorphism. You can use polymorphism to make implementations easier, but polymorphism is just implementation detail. It's about binding time. It's about when do you make things more flexible to change. And when you start looking at the really sophisticated patterns for things like fault tolerance in distributed systems, patterns for trying to identify insider threats in organizations, the fact that there's polymorphism involved is completely in the noise. By the way, I should also mention that many, if not all, of the Gang of Four patterns also can be implemented in non-object-oriented languages like C. And in those languages, of course, you get polymorphism in a slightly different way than you do in C++ or Java or C#. You do things like have tables of pointers to functions and so on. And those patterns all apply. If you take a look at Unix or Windows, the open, close, read, write implementations use the bridge pattern. And there's just patterns galore. If you ever look at the qsort method that's used to sort an arbitrary array in C, in the standard C library, that uses the strategy pattern. So there's lots and lots of patterns that have little or nothing to do with the use of virtual functions, although certainly patterns often use polymorphism in object-oriented environments because that's a natural way to get extensibility and systematic reuse. Let's see. Yep, good point. Take a look at all the various kinds of mechanisms for notifying things. All right, if I understand right, if two flows wait condition and the third then involves signal method to lock on this condition. Well, so you're basically right, but you have to be prepared for a signal call to wake up more than one waiter. And if you take a look at some of the links that I have in my video, it talks about why this is the case. It's called spurious wake-ups, and it has to do with ways in which people implement things in multiprocessor systems. So the long and the short of it is, you should always write your programs that use guarded blocks or guarded suspension pattern to use a loop to check to see whether or not the condition is what you want before proceeding. And that way, whether signal or signal all is called, it doesn't really matter. Everything works out just fine. So I won't talk about this in detail now unless people are curious, but if you take a look at the guarded suspension pattern and you read the discussions and you watch the video, you'll see why you should always call these things in a loop. And that just guards against all these various kinds of weird problems. No week 2. I'm not sure if that's a question. I tried fair and unfair, but didn't make any difference. Sorry. Yeah, I don't know why it would take you so long to run. If you search on the discussion forum, there's a bunch of discussions about why or how to optimize the readers writers lock example, and I'm going to show you this in just a second. So we'll talk more about that. Will you evaluate the security aspect of Android content provider? So if you've been paying attention on the discussion forums and the announcements, you'll see that we have about 2.5 hours worth of videos uploaded on Android security topics. They're up on Professor Jules White's YouTube site. So I recommend you go take a look at those videos and see if he covers what you're looking for. But that's the part in the class where we would cover that. When will we start improving I Remember? That will be the 8th and final assignment in the course. Remind me, please, what is inversion of control? Go back and watch the first 10 minutes of the video. When I put it up later, we talk at length about inversion of control. Why is the programming assignment in week 3 not about Android concurrency frameworks? Just because I wanted to have people get one more chance to play around with some of the basic building blocks before we launched into the concurrency framework stuff in Android. It'll catch up next week. Why do both application activities and service perform in one main thread? Why does service not have its own thread? So that's a very, very good question. I recommend you go and take a look at the following document. Let's go ahead and pull this stuff up so you can see why that's the case, or you can see that it's the case. We'll leave it as an exercise to the listener to figure out why it's the case. Android service. So if you go to Android service, there is a wonderful discussion about Android services, and so you can read all about this stuff, and somewhere it'll tell you that it basically doesn't have its own thread. And let's see if I can search for it. There we go. says right here, a service runs in the main thread of the application that hosts it by default. Here we go. It even has a caution. A service runs in the main thread of its hosting process. The service does not create its own thread and does not run in a separate process unless you specify otherwise. Blah, blah, blah. So that is what it does. As to why it doesn't have its own thread by default, that would be an excellent question to post on one of the Android developers forums. I don't have insight into the mind of the people who did it, but I will say that creating a service with a thread is absolutely monumentally simple. The easiest way to do it is to use the intent service framework, which also uses the template method. It's basically a combination of the command processor pattern and the template method pattern, and it's just awesome. So we'll cover that very shortly. Let's see, and I think this is just pointing out that services run on their own thread. This is another good point. Thank you for reminding me about this. So if you have interfaces, you can have a class that inherits multiply from many interfaces, but you can only have a single class, and then that's why they have interfaces. So you can do that. Let's see. In the ping pong console program, I still don't get how the program knows when to use the semaphore and when to implement the other way of execution. Okay, that's a great question. Now, I'm going to assume that you've watched the video, and so what I'm about to show you is basically just redundant with what's in the video, but it'll help. So if we go here and we take a look at make ping pong threads, that is a factory method using the good old factory method pattern. And if you come down here to the run, this is the main program that is the main run function for the whole thing. It calls make ping pong threads, and you can see it passes in the sync mechanism. And if you go over here to the options method, you see that it has this thing called sync mechanism, and sync mechanism can be set by an option that you pass in. I think it's the the minus S option. So if you pass the minus S option in on the command line when you start up, it'll go ahead and start with that. So that's how you indicate which one you want. And then make ping pong threads is a factory method, and it comes in there and it says, is the person trying to make an implementation or configuration of the ping pong's program that uses semaphores? If so, here's how we initialize it. And then it says, is it trying to do something that uses conditions? If so, then we initialize it, and so on. So as you can see here, we put all that complicated code that figures out which of the two implementations to choose into the factory method, and then down here we go ahead and simply grab that appropriate mechanism, and that's what we use. All right, let's see. That's not a question. Let's see. So I think, there's a question about data flow. I assume data flow diagrams are, I do data flow diagrams and sequence diagrams and so on for some of the stuff, but I have not had a chance to do them for the assignments yet. But that should be easy. If you get a tool, you should be able to generate themselves. I made the silly mistake of passing the consumer runnable to the producer and the producer runnable to the consumer. Will the behavior be different? No, they should basically behave the same. Let's see. People wanted to know if we can do an overview assignment 1. Yes, absolutely. We're going to do that in just a second. Can you make a brief tutorial on how to use ObjectAid? It's really simple. You just basically open it up. Once you install it, you open it up, and then you indicate which classes you want. You kind of drag them in, and it just puts it right in a window. It took me about 5 minutes to figure it out by watching the tutorial. Real simple. Many threads on the forum are deleted, but the titles are still popping up in search. Yep, I've noticed that too. It's kind of weird. Let's see. There's the ObjectAid stuff. Very cool. Is it possible to have a bigger screen? Probably. How is the source code in the grading driver different from the master directory? So So far, they've basically been identical. This is basically something I did as a way to be able to make improvements to the grading after we've released the assignment. So if people, after we officially release the assignment, if somebody says, my gosh, there's a huge bug in your program, or here's a great way we can improve that, and if only you would make this change to the JUnit test or the Robotium test that we'll use later when we get to Android, that would make everything so much better. If that happens, and it hasn't happened yet, but if it happens, I want to be able to put that into the grading drivers directory, and then when people do the peer assessment, which always occurs 2 weeks after the assignment's been released, they will use, hopefully, the correct version, not the original version. So it's just a way of trying to future-proof my design. Here's another example of a UML modeler. Okay, what I'm going to do now in the remaining time is I'm going to go over the next week's assignment so you can kind of see how it works, and more importantly, how to do it and how to grade it. So let's go ahead and bring this up, and I will also see if I can make my screen a little bigger. I think that's about right, though. The code shouldn't be too much bigger than that. All right, so let's drop out of this guy, and then we will go to the assignments. This is what you're going to see. Here's week 2, assignment 1. Mercifully, we only have one. We only have one version of this, so that should be less confusing. In this assignment, you're going to implement the simple atomic long class using a Java read-write lock. As we talked about on the forum, there's other ways to do this. In fact, if you look at the actual implementation of the code in Android, it's not done quite the way we're doing it. It's probably done better, but I wanted to have something simple to illustrate read-write locks. So what you're going to do to implement this is go into the directory, and you're going to pull up this file, which is simple atomic long, and you're going to fill in some to-do items. So here, of course, you're going to have to create the read-write lock. As we talked about before, you don't have to make it fair. In fact, that'll just slow things down. You'll then have to go ahead and fill in the simple atomic long constructor to initialize it. Make sure you initialize the value, which is called m value, with the initial value, and not something else. And then here are the actual skeletons. Now, let me say this very carefully. I don't care how you implement this stuff inside these methods as long as it's correct and as long as it's understandable to people reviewing it. When I first started this thing out, I was going to use these long values to just kind of make my critical section shorter, and that's certainly a thing you can do. I decided ultimately I didn't like that approach, so feel free if you want to go in and gut the implementation of these methods. Don't add new methods, but you can gut the implementations. I don't care. Just make sure it's comprehensible to the person who reads it. You'll also find out that for the get method, you need to use a read lock, and then for all the other methods, you need to use write locks. I strongly encourage you just to use write locks. The critical section is so tiny, it's not worth trying to do anything fancier than that. If you had more complicated logic, then you might want to split it up, and you might want to have the read locks and the write locks be separate, and so on, like we show in the Bluetooth socket example in the video. But for this one, just grab a write lock in these guys and do your thing. The methods here are really mimicking the behavior of pre and post increment and decrement in C++ and Java and C. That's all they're doing. It's very simple. I personally decided to use a try finally block for my implementation. It's not actually strictly necessary for this particular case because you can't interrupt these guys. They don't block on anything that's interruptible. But I found that it just was more convenient to do it that way, and that way if I ever was to modify this code, I would have saved myself a headache if I added some more logic somewhere that could be interrupted, so I'd use try finally. You don't need to use tried finally. It's not part of the rubric. It's clearly stated it's not part of the rubric, so if people do it differently, that's okay. You do have to make sure you unlock the lock before you exit, of course. But you can do that multiple different ways. So there's plenty of flexibility here. But the key thing is to make sure that you do the proper acquisition of the right kind of lock, which is a read lock for get and a write lock for all the other ones. People have also asked questions about whether or not you should do things that use have an internal method like get impl or something that gets the value without grabbing the lock. You could do that, but it's such a short amount of code. It's one line of code in the critical section. It's probably not worth it. It's probably overkill. So, so that's basically all there is to it. I mean, again, this is intentionally very simple. I wanted people to get some experience with concurrency. For those of you who already know this stuff, you may be bored. I've given recommendations on other things you can do. You can work ahead on the later examples. You can implement other stuff from my CS282 class if you feel up to it. But I'll let you decide what you want to do. So hopefully there are no other questions about this. It's really, really simple. Shouldn't take you long to do, and hopefully there's not a lot of surprises. Let's see. Here's a question. What's the difference between notify and signal? Notify is what's used for the built-in Java monitor objects, whereas signal is what's used for the condition objects. They do essentially the same thing. They're not implemented quite the same under the hood. As mentioned in the video, the Java built-in monitor objects use POSIX, POSIX mutexes, and condition variables, whereas the Java condition objects use something that's a little bit different than that, but it's basically along the same lines. Let's see. Shouldn't permit number in assignment 3 be a member variable of condition object rather than a member variable of simple semaphore? No, permit number really needs to be a member variable of simple semaphore. It shouldn't be a member of, I'm not even sure what it would mean to be a member variable of condition object, because that's something we don't have any control over. So you don't control the condition object. So if you take a look at the condition object video, it's really quite simple. Because the condition object video shows you a somewhat more complicated example, but strips it down a little bit. Here's another question: Does a condition object always use reentrant lock for guarded? I think you can use other kinds of locks, but the most common one is to use reentrant lock. In fact, this is a good reminder. We're kind of running out of time here, but I did say I would cover the stuff that's also in the Virtual Office Hours website. So let me pop over there real quick for people who are still interested, and of course all this stuff will be available online later. Let's go take a look here. I think this is one of the questions that was also posed there as well. Okay, so question on assignment 1. Let's see. For assignment 1, if all the checks in the JUnit test pass, is it safe to assume the code is correct? It is never safe to assume that code is correct just because the tests pass. It is more likely that there aren't obvious bugs if the tests pass, but as we have seen, as peer reviewers have reported, people come up with some pretty creative ways to write incorrect code. So that's why it's important to also go ahead and check the code by human means as well. So I wouldn't make any assumptions whatsoever, although you get greater confidence. Hammer versus async task. I think this has probably been already answered. So take a look at the videos coming up next week, which are on my YouTube channel, for a nice comparing and contrasting of these different things. Suresh brings up an interesting point, which is also covered in the videos. If you take a look at the async task documentation, it says it's ideally used for short operations. And that's if you use the default implementation of async task, which uses a single-threaded executor, or so-called sequential executor, thread pool executor. However, once you watch the async task video, you'll know how to trivially change your async tasks to use a pool of threads, and then you can run operations that take a long time, and everything will be fine. Again, Suresh also points out that async tasks are more limited. That's covered in the video, and they're much easier to use. They're definitely much easier to use. It's almost you know, trivially easy to use async tasks. Very, very simple things to do. Let's see. By the way, async tasks are also a really cool example of the half sync, half async pattern, which we'll cover later. Here's the question: do you always use conditions of the reentrant locks? You can use lock, but reentrant lock is the most common lock. Suppose you could implement your own kind of locks. Peer grading question: did they use version 2? So we talked about that in virtual office hours, and I said, feel free to take a couple points off if they didn't follow the instructions, but give them points for things that were done correctly. We're not trying to be overly picky, but it's important to learn to follow instructions if you want to write software, because you're going to be confronted with specs and requirements and deadlines and customers that change their minds at the last minute, and you've got to be prepared for that. So you have to pay attention. Let's see. Emulator. Yeah. So obviously you don't use the emulator. You just use Java Eclipse. I didn't think that there was anything about emulator still in the assignment description. If it is still in there, please let me know, and I'll go back and remove that. But I don't think it says. I think it just says use Eclipse. An earlier version may have said something more. Okay, I think we've answered all of those questions. Let's see if there's any more questions here. Why is the lock package imported in almost all the first 3 assignments? Because I actually use it in my implementation. My implementation uses the lock package. I use lock specifically out of that. It's not required to do that. I don't know why people are obsessed about this, but if you don't like it, take it out. Not a big deal. But I used it in my implementation. It's not an error to have additional imports. Nobody will come and revoke your programmer's license. For fair, we use signal, and not fair, use signal all. I don't think that those things are really they're orthogonal concepts. Fair and unfair, signal all are really not related to each other. What's the priority of threads in Java and in Android? So you can control thread priority when you do various things. That's one of the options that you have at your disposal. And so if you read the threads documentation, you'll see how you can set the priorities of the threads. And so I recommend you take that. I think they'll just start out with the default priority, whatever that happens to be on a given platform. All right, that's already answered. I told you I used the lock package myself, and so I left it in there. But if you don't use it, feel free to take it out. Please explain the acquire release policy of the code before. Can it deadlock? Well, it's kind of hard to read the code, but let's see. Lock wait. Not quite sure what lock is in this case. Is it if lock is a condition object, and I'm really confused. Yeah, I don't understand. I don't understand the example. So why don't you go ahead and post this on the discussion forum, and we'll take a look at it. But it's not really clear to me what you're doing. But yeah, it's pretty easy in Java to or in any tool, not just Java, but anything that uses these synchronization primitives. It's pretty easy to get deadlock, and so you have to be very careful about that, especially object-oriented environments with callbacks. By the way, that's the reason why you have these reentrant locks. It's trying to minimize the opportunity for self-deadlock, which is also discussed in the thread-safe interface pattern from the POSA 2 book, and I've given those links various places. Okay, so are there any other questions? Does anybody have any other questions that they'd like to have answered? If not, I thank you guys all for your time. We will, as soon as I have a chance to get this video downloaded to my machine and do a couple of fun things to turn it into a better looking background than bright green, I will do so, and hopefully we'll get a chance to talk again real soon. Please make sure that you read the deadlines and continue to ask all the great questions on the discussion forum. Thanks very much. I'll see you later.